Now coming to the lab 7 of the interfacing. So in this lab we will program the PWM with the CCP module. So initially we have to calculate the PR2. So the given frequency is 30 kilohertz and the crystal oscillator is 20 megahertz. So we have found that the PR2 is 165.66, so it is rounded off to 166. So as you can see, it is less than 255, so there is no prescaler. So for the 0% duty cycle, we have the CCPR1L equals to 0 and the decimal point is also 00. So we have taken the 00 as you can see here. So the CCP ICON equals to 0C. So for the next 25% duty cycle, we have get the value of 41 for the CCP RIL and the decimal point is zero point 0.5. So we have taken 10. So the CCP ICON equals to 2C, and for the next 50% duty cycle we have get the value of 83, and here we have the decimal point is 00. So CCP ICON equals to 0C, and for the next 75% duty cycle we have got the value of 124. In this case the decimal point is zero point 0.5, so the CCP ICON equals to 2C, and for the last 100% duty cycle we have got the value of CCP R1L equals to 166, and in this case we have the decimal point 00 for the CCP ICON equals to 0C. Now coming to the program, so as you can see here, for the 25% duty cycle I have created a function named PWM25. So initially I have set the value of PR2 equals to 166 and CCP-R1L equals to 41 and CCP1 CON equals to 2C as per the calculation. Now next for the 50% duty cycle it is 83 and OC, and now for the 75% it is 124 for the CCP R1L and 2C for the CCP1 CON, and for the 100% it is 166 for the CCP R1L and CCP1 CON equals to 0C, and for the last 0% I have created a function named PWM 0. So here the value of CCP R1L equals to 0 and 0C for the CCP1 CON. Looking at the main function, so you can see that the port is set to the input, so as indicated equals to 1 to read the input from the button. Next the port C is set to the output, that is indicated as 0, and the RC2 is, so the RC2 pin is initially 0, that is low. So next coming to the while loop, that is the infinite while loop. So if the button is pressed, that is RE2 equals to 0, the LED will first glow at the 25% duty cycle. So again if the button is pressed, the X equals to 1, the LED will glow at the 50% intensity, and again if we So again, if we press the button, that is the x equals to 2, the LED will glow at the 75% intensity. As you can see, there is a function named PWM 75. And for the next step, if the button is pressed, that is x equals to 3, the LED will glow at the 100% density. And at the last, if the button is pressed again, that is x equals to 4, the LED will go back to the 0%. So again, if the button is pressed to, so the LED will go to the 25%. So as long the button is pressed, the loop will go on. So this is the program. So now we will build the program again. So as you can see that the build is succeeded. Now I'll just build again, and now I'll connect the picket 3, the none, connect picket 3. So as you can see, the picket 3 is connected. So now I'll just do the blank. First we'll do erase, and then I'll do the blank check. And now I will load the program. No. So as you can see, the program verify complete. Now I just put positive end of the LED is connected to the 17th pin of the microcontroller, and this 17 pin is RC2 or CCP1, and the negative end of the LED is connected to the resistor, and the resistor is of 470 ohm, and the negative end of the resistor is connected to the ground. So after pressing the button for the first time, the LED which is connected to the RE2 port, the LED will glow with the 25% of the intensity, as you can see here. 25, and again 50, and again if I press the button, the LED will glow with 75% of intensity. 75, and again with 100% of the intensity. And now if I press the button, it will go back to the 0%, as you can see. So as you can see, 25, 50, 75, and 100, and again 0. So this is the full demonstration of the lab 7 of the interfacing. Thank you.